Hi everyone, my topic is Newton-Raphson method. Our aim is to find any two minima of the function f of x equal to sin x into ln x between x equal to 0 and x equal to 20 using Newton-Raphson method. First of all, let's look at the theory of the experiment. Newton-Raphson method, named after Isaac Newton and Joseph Raphson, is a root-finding algorithm which produces successively better approximation to the roots of a real-valued function in numerical analysis. This method is generally used to improve the result obtained by another methods to get roots. Now consider x0 be an approximate root of f of x equal to 0 and let x1 equal to x0 plus h be the correct root so that f of x1 equal to 0. Now expanding f of x0 plus h by Taylor series, f of x0 plus h into f dash of x0 plus h square by 2 factorial into f double dash of x0 plus etc. equal to 0. Now neglecting the second and higher order derivatives, we get f of x0 plus h into f dash of x0 equal to 0. Therefore, h equal to minus f of x0 by f dash of x0. A better approximation than x0 is therefore given by x1, where x1 equal to x0 minus f of x0 by f dash of x0. The successive approximations are given by x2, x3, etc. xn plus 1, where xn plus 1 equal to xn minus f of xn by f dash of xn. This is the Newton-Raphson formula. We give from iterative method xn plus 1 equal to phi of xn. Therefore, phi of x equal to x minus f of x by f dash of x. So we get the derivative of phi of x as phi dash of x equal to f of x into f double dash of x by mod f dash of x whole square. To examine the convergence, we assume that f of x, f dash of x and f double dash of x are continuous and bounded on any interval containing the root x equal to zeta of equation f of x equal to 0. If zeta is a simple root, then f dash of x not equal to 0. Further, since f dash of x is continuous, mod f dash of x greater than or equal to epsilon for some epsilon greater than 0 in the suitable neighborhood of zeta. We can select an interval such that mod f of x into f double dash of x less than epsilon square. And since f of x is continuously twice differentiable, hence in this interval we have mod phi dash of x less than 1. Newton-Raphson method is an open approach where optimum of one-dimensional function f of x is found using an initial guess of optimal value without specifying lower or upper boundary values. We can find the minimum and maximum of a function f of x. The derivative is 0 at a minimum or maximum. So local minima and maxima can be found by applying Newton's method to the derivative. Before using Newton-Raphson method to determine the minima or maxima of a function, one should have a reasonably good estimate of the solution to ensure convergence, and that the function should be easily twice differentiable. Now let's look at the algorithm of the program. First of all, define the function as fn of x. Then read the value of x1. Now the value of h is given as h equal to 0.01, and then read the number of iterations as n. Now a for loop is introduced such that for I in range n, we execute the steps from 6 to 13. That is, y becomes fn of x1, y1 becomes fn of x1 by minus h, and y2 becomes fn of x1 plus h. Now the slope is given as slope equal to y1 minus y2 by h by 2. Now s slope is given as s slope equal to y1 plus y2 minus 2 star y by h by n. And x2 becomes x1 minus s slope by slope. Now the value of x2 is given to x1. That is, x1 becomes x2. Now print the value of x2 and fn of x2. Then repeat the steps from 6 to 13 until the condition I less than or equal to n is reached. Then a condition is given that if slope is greater than 0, print the minimum of a function as x2, or else print the maximum value of the function as x2, and then stop the program. Now let's look at the program. The program is to find the maxima and minima using Newton-Raphson method for the function sin of x star ln x. First of all, we have to introduce the module. So give from pylab import star. In this program, we have to use some mathematical functions such as sin, log, etc. So we have to import the math module also. So we give from math import star. Now define the function fn of x and return sin x star log x. x1 equal to input of enter the value of x1. That is, the value of x1 is given as input. Here we take the value of h as 0.01. So we give h equal to 0.01. N equal to input of how many iterations. Here we enter the number of required iterations to n. Now a for loop is introduced such that for I in range n, we execute the following steps. Y equal to fn of x1, y1 equal to fn of x1 minus h, y2 equal to fn of x1 plus h, and the slope is given as slope equal to y1 minus y2 by h by 2, and s slope is given as s slope is equal to y1 plus y2 minus 2 star y by h by n. Now x2 is given as x2 is equal to x1 minus s slope by slope, and the value of x2 is given to x1, that is x1 equal to x2. Now print the value of x2 and fn of x2. This loop will continue to execute until the condition I less than or equal to n is reached. Now another condition is introduced that if s slope greater than 0, print the minimum of the function equal to x2, or else we print the maximum of the function equal to x2. Thus we get the minimum or maximum of a function through the program. If you have to find two minima of the function, you have to run the program many times until you obtain two minima. For that, give the values for x1 in between 1 and 20, and you will get minimas at x1 equal to 5, 6, 12, 18, etc. And that's all about my topic. Thank you.